Any sailor knows that specific heavy feeling when a loaded ship stops answering the helm exactly when you need her to turn. You watch the jackstaff drift slowly away from your leading mark, and you realize the force of the water against the hull has become stronger than the rudder. It is not a loud moment, but it is the moment when a routine maneuver changes into something that requires absolute focus. We were approaching a medium-sized port on the Atlantic coast, inbound with a full cargo of grain. The vessel was a standard bulk carrier, about 40,000 deadweight tons, a reliable ship that I had commanded for 2 years. We were down to our marks, drawing close to 11 meters. The approach to this particular harbor requires a vessel to line up with the entrance buoys about 2 miles out, keeping a steady course between two stone breakwaters that protect the inner basin. It is usually a straightforward run, provided you respect the tides. On this afternoon, the weather was not ideal, but it was not severe enough to close the port. The wind was blowing force 5 from the northwest, hitting us on the port beam as we made our final approach. There was a moderate swell running, perhaps 2 meters, rolling in from the west. The pilot station had advised us that the pilot launch was having trouble coming alongside due to the swell, so I was asked to proceed to the inner breakwater where the water was calmer and board the pilot there. This was not uncommon, though it meant handling the entrance maneuvering without local advice on the bridge. The bridge team consisted of myself, the third officer handling the telegraph and logbook, and an experienced AB at the wheel. We had the charts laid out and the radar running on the 6-mile scale. The engine was on standby, turning at slow ahead to maintain steerage way in the following swell. The visibility was clear, but the gray water in the whitecaps made it difficult to gauge the exact speed of the current running across the harbor mouth. Before I tell you what happened next, please consider subscribing. It helps this channel reach more sailors. This happened in 1988 on a routine commercial voyage. The approach began normally. I aligned the vessel with the leading lights, which were clearly visible on the shore behind the breakwaters. We had about 1 mile to run before passing between the breakwater heads. The chart indicated a cross-current running south to north across the entrance, which I expected to push us to starboard. To compensate, I ordered the helmsman to steer 5 degrees to port of the course line. This crabbing angle is standard practice to counteract the drift. At first, the vessel held the line well. We were making about 6 knots over the ground. I watched the leading marks, 2 orange triangles on the far pier, staying in line. The third officer called out distances every few minutes. 1 mile to the entrance, he said. I checked the radar. The breakwaters were distinct, solid yellow bands on the screen. Then the situation began to change subtly. As we closed to within half a mile of the entrance, the protection of the land diminished, and the wind funneling down the coast hit us harder on the port quarter. Simultaneously, the current seemed to intensify. I noticed the bow swinging slightly to starboard, pushing us away from the center of the channel and toward the southern breakwater head. "Port 10, I ordered. "Port 10, the helmsman repeated. He turned the wheel and I watched the rudder angle indicator move. The ship reacted, but sluggishly. The heavy swell following us was lifting the stern and confusing the water flow around the rudder. Instead of bringing the bow back firmly to port, the vessel merely stopped swinging to starboard. We were still drifting sideways, closing the distance to the southern breakwater. The gap between the 2 stone arms looked narrower from the bridge than it did on the chart. I needed more rudder authority. The propeller wash at slow ahead was not providing enough push against the rudder blade to overcome the combined force of the wind and the current. "Half ahead," I said. The third officer rang the telegraph. The engine room answered immediately, and I felt the vibration increase slightly through the deck. The ship picked up a little speed. "Midships, port 20, I ordered. The helmsman spun the wheel. "Port 20, sir." We were now a quarter mile from the entrance. The southern breakwater, a long wall of rough granite blocks, was visible off the starboard bow. I could see the waves breaking against the base of the structure. The drift had not stopped. Despite the increased engine kick and the rudder angle, the mass of the loaded hull was still sliding sideways. The drift angle was significant now, perhaps 15 degrees. We were crabbing, but the set was pushing us bodily toward the stones. The hydrodynamics of a ship in shallow water can be unforgiving. As we neared the breakwater, the water depth decreased. This creates a cushion effect. But in this case, the cross current was the dominant force. The water moving across the harbor mouth was hitting our port side and simply shoving the 40,000 tons of steel to starboard. I walked out to the starboard wing of the bridge to get a clearer sight of the gap. The distance to the southern breakwater head was shrinking. If we continued on this vector, the starboard quarter would likely brush or strike the submerged rocks at the base of the breakwater as we passed. I stepped back inside. "Hard to port," I said calmly. "Hard to port," the helmsman replied. The wheel hit the stop. The rudder was hard over. The engine was at half ahead. The bow began to swing to port, bringing us back toward the center of the channel, but the stern was still sliding toward the danger. The ship was pivoting, but the momentum was carrying us sideways. It was a matter of timing. If I increased speed further to full ahead, I would gain steerage, but I would also reach the breakwater faster, leaving less time for the rudder to bite. If I slowed down to maintain position, the current would take total control and we would drift helplessly onto the stones. I watched the bows. It was swinging too far to port now, aiming us at the northern breakwater. The vessel was yawing in the swell. I had to arrest the swing, but I couldn't take the rudder off yet because we needed the lift to keep the stern clear of the southern wall. The third officer looked at me. He did not speak, but he had stopped writing in the logbook. He was watching the breakwater head passing close down the starboard side. We were committed to the entrance now. There was no room to turn around and no time to stop. The vessel was heavy, the water was moving, and we were sliding into the gap with the ship pointed at a sharp angle to the channel. "Starboard 20, I ordered, trying to catch the swing before the bow crossed the center line. The helmsman turned the wheel rapidly to the right. The rudder angle indicator swung from hard port to starboard, but the ship, heavy with grain and deep in the water, did not want to stop her swing. The momentum of the turn was established. The bow continued to swing to port, aiming directly for the incoming pilot boat that was waiting just inside the calmer water. We were entering the harbor mouth sideways, fighting the wind, the current, and our own inertia. The engine revs were steady, but the ship felt loose, sliding on the surface of the water rather than cutting through it. I watched the stone wall of the northern breakwater filling the view in the front window. The tension on the bridge was silent and heavy. As the stern cleared the breakwater heads, the behavior of the vessel changed instantly. We passed from the rough driving water of the open sea into the protected basin of the harbor. The heavy swell that had been lifting the quarter disappeared, blocked by the stone walls. More importantly, the strong cross current that had been pushing the hull to starboard vanished. However, the rotational momentum we had built up did not vanish. To fight the current outside, I had the rudder hard to port and the ship swinging in that direction. Now, with the counterforce of the current gone, that swing to port accelerated rapidly. The bow, which had been pointing safely toward the center, began to sweep aggressively toward the northern breakwater and the shallow water at its base. The wind was still blowing force 5, but now it was coming over the breakwater, catching the accommodation block and the high freeboard of the stern. This pushed the stern further to starboard, which pivot turned the bow even sharper to port. The third officer spoke quietly. "Heading swinging fast. Port 280, port 275. I walked to the front window. The pilot boat, which had been waiting for us in the lee of the north wall, suddenly realized our trajectory. I saw the coxswain rev his engines and turn sharply away, creating a white wake as he scrambled to get clear of our bow. He could see that a 40,000-ton ship was aiming directly for the water he was floating in. "Midships, hard starboard," I ordered. "Hard starboard," the helmsman repeated. He spun the wheel rapidly. The rudder angle indicator moved to 35 degrees starboard. I waited. The ship was still making about 5 knots. At this speed, with a loaded hull, the reaction to the rudder is never instant, but usually you see the rate of turn slow down on the gyro repeater. I watched the repeater. The numbers were still clicking down. 270, 265. The swing to port was not stopping. The inertia of the cargo was carrying the turn, and the shallow water inside the breakwater was creating a cushion effect that seemed to resist the rudder. The distance to the north wall was now less than 3 cables. Beyond the stone wall, there was a visible mud bank where the chart showed a depth of only 5 meters. We were drawing 11. If the bow continued on this arc, we would run hard aground within 2 minutes. The engine was still at half ahead from the entrance maneuver. The propeller wash was flowing over the rudder, but it wasn't enough to break the swing. The ship felt heavy and unresponsive, sliding on the slick water of the inner harbor. "Full ahead," I said. The telegraph rang. I needed the kick effect. By increasing the propeller RPM to the maximum, I hoped to send a strong burst of water against the hard over rudder. This sudden pressure is usually enough to shove the stern to port and force the bow to starboard, correcting the shear. The vibration on the bridge increased as the main engine load came up. I gripped the rail and watched a fixed point on the shoreline, a warehouse roof relative to our jackstaff. For a few seconds, nothing happened. The ship simply accelerated toward the danger. Then, very slowly, the rate of swing began to decrease. The clicking of the gyro repeater slowed, but it did not stop. We were still turning to port, just more slowly. The warehouse roof was still moving to the right of the jackstaff, meaning the bow was still moving left. We were running out of water. The pilot boat was now safe, well off our starboard quarter, but the pilot was on the VHF radio. "Captain," the voice came through the speaker, calm but urgent, "you are getting close to the north bank." "I see it," I replied. I had to make a choice. If I kept the engine on full ahead, I might gain enough steering power to turn away at the last second. But if I failed, I would hit the bank at 7 or 8 knots. That kind of impact would breach the hull plates and likely damage the inner bottom. On the other hand, if I stopped the engine, I would lose all steerage from the rudder. The ship would become a drifting dead weight. How would you handle this from the bridge? I looked at the water over the side. We were moving too fast. The kick ahead had given us speed, but it hadn't given us enough turn. The geometry of the approach was broken. We were too far to the north side of the channel to recover with the rudder alone. "Stop engine," I ordered. "Stop engine," the third officer answered. The vibration died away. "Full astern." The telegraph rang instantly. This was the only option left. I had to rely on the transverse thrust of the propeller. On this ship, we had a standard right-handed fixed-pitch propeller. When the engine runs ahead, it pushes the ship straight, but when you put the engine astern, the rotation of the propeller tends to kick the stern to port. If the stern kicked to port, the bow would pivot to starboard. That was exactly the motion I needed to avoid the bank. It took about 20 seconds for the engine to stop firing and the starting air to kick in for the reverse rotation. Those 20 seconds felt very long. The ship coasted silently, still swinging slightly to port, closing the gap to the mudbank. I could see the texture of the rocks on the breakwater wall clearly now. Then the engine caught. Whoosh thump. The heavy rhythmic beat of the diesel going astern began. "Emergency full astern," I said, just to ensure the engine room gave me everything they had. The tachometer needle climbed. The water around the stern began to churn. I walked to the wing. Brown mud was being churned up in our wash, indicating we were already influencing the shallow bottom. The effect of the transverse thrust is not immediate. First, the propeller has to overcome the forward momentum of the water. Then it bites. I watched the bow. It hung there, pointing at the rocks. Then, as the propeller wash traveled forward along the hull, the friction slowed the ship. Simultaneously, the stern began to walk to port. Visually, it looked like the bow was finally moving to starboard. The warehouse roof on the shore stopped moving relative to the jackstaff. Then slowly it began to shift the other way. The swing to port had stopped. "Midships," I said. "Rudder amidships." "Midships," the helmsman said. There was no point using the rudder now. With the engine going full astern, the water flow over the rudder is confused and ineffective. Steering is done entirely by the propeller's torque. The ship shook heavily as the engine fought the forward momentum. Our speed over the ground dropped rapidly. 4 knots, 3 knots, 2 knots. The bow was safe. The transverse thrust had twisted the ship just enough to parallel the channel. We were perhaps half a ship's length from the edge of the navigable water, but we were no longer turning toward it. "Stop engine," I ordered. The silence returned. The ship was effectively stopped in the water, drifting slightly but aligned with the inner harbor channel. The pilot boat, seeing we were under control, approached our starboard side again. "Dead slow ahead," I said, to regain barely enough steerage to meet the pilot. "Hard to starboard." I wanted to get the bow well away from that bank before we picked up any speed. The third officer let out a long breath. He picked up his pen and noted the time in the bell book. The crisis had lasted perhaps 4 minutes from the moment we cleared the breakwater heads. We were now drifting gently in the turning basin area. The danger of grounding was past, but we were in an unusual position, far over on the north side of the harbor. I needed to bring her back to the center to safely transit to the berth. The vessel lay nearly dead in the water, drifting almost imperceptibly on the calm surface of the inner harbor. The sudden silence after the heavy vibration of the emergency astern maneuver was noticeable. On the bridge, the atmosphere shifted instantly from immediate crisis management to routine arrival procedure. There was no cheering or loud exhaling, just the quiet shuffling of feet as the third officer moved to the chart table to plot our position. We were safe, but we were out of position. The ship was aligned with the channel, but we were too far to the north, favoring the side where the water shoaled. "Pilot boat alongside," the third officer reported. I looked over the starboard wing. The pilot launch was bobbing against our hull. A minute later, the pilot entered the bridge. He was a local man, calm and efficient, shaking the rainwater from his coat. He looked at the chart, then at the window, then at me. "Good morning, Captain," he said. "I saw you swinging a bit wide there." "Good morning," I replied. The current cut off sharply inside the breakwater. She carried the swing. "It happens," he said simply. "The transition there is sharp. You caught her just in time." That was the entire discussion regarding the near grounding. In this profession, when a maneuver works, there is little need to dissect it immediately. We had work to do. "We will need to crab back to the center," the pilot said. "Tugs are waiting for us half a mile ahead." "Very good. She is yours," I said. The pilot ordered dead slow ahead and starboard 10. We needed to gently nudge the bow away from the northern bank while gathering just enough headway to reach the tugs. The engine answered, and at this low speed, the ship behaved predictably. We watched the rudder angle indicator carefully. I kept an eye on the echo sounder. It showed 2 meters of clearance under the keel, shallow, but sufficient for this harbor. 10 minutes later, we met the tugs. They were standard harbor tugs, not the powerful tractor tugs you see today, but reliable. One made fast on the starboard bow, the other on the starboard quarter. "Make fast," the pilot ordered via the UHF radio. I relayed the order to the chief officer on the bow and the second officer on the stern. The radios crackled with confirmation. Once the tow lines were secured, the tension on the bridge dissipated completely. With tugs attached, the variables of wind and current became manageable. We proceeded to the grain terminal at a speed of 3 knots. The pilot used the forward tug to control the bow, keeping us strictly in the center of the fairway. The wind was still blowing over the breakwater, but inside the basin, the water was flat. The ship felt heavy and stable again. As we approached the berth, the operation became a matter of finesse. The grain terminal was a concrete wharf with a conveyor system. We had to land a 40,000-ton vessel against the fenders without damaging the structure or the ship. "Stop engine, Tama," the pilot said. We coasted. The distance to the berth was 3 cables. "Dead slow astern," the pilot ordered. He wanted to take the way off the ship completely before we used the tugs to push her alongside. The engine kicked astern gently. The wash reached the midship section, and the vessel stopped moving forward. We were now parallel to the berth, about 50 meters off. "Push on, easy," the pilot told the tugs. I watched from the port wing. The tugs applied power. Slowly, the gap of dark water between the hull and the concrete wharf began to close. I watched the fender line. It is easy to misjudge speed when moving sideways. If you hit the fenders too hard, you can dent the hull plating or crush the fender rubber. "Half meter per second," I said to the pilot, estimating our lateral speed. "Ease up," the pilot told the tugs. The tugs reduced power. The ship drifted in the last 10 meters on her own momentum. The first heaving lines were thrown from the deck to the linesmen on the shore. Then the heavy mooring lines followed, springs first, then headlines and stern lines. There was a soft bump as the parallel body of the ship made contact with the fenders. The ship settled. "All fast," the chief officer called from the bow. "Finished with engines," I said to the third officer. He rang the telegraph. The engine room acknowledged. The voyage was officially over. I checked the clock. It was only 40 minutes since we had passed the breakwater heads, but it felt like a full watch. After the authorities had cleared the vessel and the cargo operations began, I sat in my office to write the note of protest, a standard formality to protect the owners in case any damage was found later. Though we had not touched the bottom, I reflected on the incident. The cause was not mechanical failure, nor was it a sudden change in weather. It was a simple misjudgment of the transition zone. When a ship enters a harbor with a strong cross current, the forces acting on the hull change sequentially, not simultaneously. As the bow entered the calm water behind the breakwater, the current stopped pushing the front of the ship. However, the stern was still outside, being pushed hard by the current. This created a powerful turning couple, a rotational force that spun the vessel to port. I had corrected for the drift, but I had not fully anticipated the rotational kick that would occur when the bow entered the lee while the stern was still exposed. Additionally, carrying that much speed, even just 6 knots, meant the inertia was too great to counteract with the rudder alone once the swing started. In the years following that voyage, I changed my procedure for that specific port. If the swell was too high for the pilot to board outside, I would wait offshore until the tide changed or the wind dropped. If I was forced to enter, I would do so at the lowest possible speed, using the engine kick only in short bursts to maintain steerage, rather than maintaining a steady speed that built up too much momentum. It is a common trap. We focus on the drift we can see, but we forget how the ship will pivot when the forces become uneven along the hull length. The difference between a routine arrival and a grounding is often just a few seconds of decision-making and a few meters of water. The sea does not care if you are tired or if the schedule is tight. It simply reacts to the physics of the hull. On that day, the physics nearly won, but the machinery and the crew held together just enough to recover. If you've seen something similar during your career, I'd like to hear it.